Thank you all for being here. Thank you for being with us remotely, and thank you, Dan, especially for coming all the way from Los Angeles to present here with us today and tomorrow at work, and then fly back to Los Angeles to be with this wonderful family. Dan needs no introduction, but for those that do not know Dan, he's obviously been extremely influential, both to me personally, way back from the 2010s onwards, and influential in what I was studying, but he's been essential on working on and digging into the metrics and the validity of these metrics and how they relate to not just stated, but also revealed preferences. And he's been working together with Ori and Miles Kimball on these kind of topics for a little while. And so incredibly blessed and honored for you to be here and to present to us the latest on this work. And I look forward to an interesting exchange with both our virtual and in-person audience. So thank you, Dan.
Thank you very much, Jan. It's a real pleasure to be here, and I'm very grateful to Jan and the Wellbeing Center for hosting me. This has been a wonderful visit. So I'm thrilled to talk with you about some of the work that I've been doing with Kristen Cooper, Ori Heffetz, Miles Kimball, and Jinan Zhao. A couple of my co-authors are joining by Zoom, and so they should feel free to jump in to help out answer questions. I know I've talked with some of you about the working paper version of this paper, and as I mentioned, the paper is evolving quite a bit, so some of what I will be saying here reflects a somewhat different perspective than what's in the written version. So the top, the application in this paper is self-reported well-being, but the topic, which is that people differ in how they use response scales, is much broader. The implicit assumption in much of this work is that people are using the response scale in the same way when they're answering these questions. So for example, they're asked their life satisfaction on a 0 to 100 scale. One person might say 70, someone else might say 80, but maybe they mean the same thing. And that's potentially a major confound for much of the work in this literature. And that's the problem that we want to think about in this paper. So one approach that's common in the economics literature is to use panel data and include fixed effects. That partially addresses the concern. In particular, it addresses the possibility that people have permanently different levels of their responses. But if those levels change over time, or if there's not just a shift, but also, as we think, a kind of stretching of the scale that differs between people, that's not going to be corrected by fixed effects. In the psychology literature, a typical approach is to reverse code, have a battery of questions and reverse code some of the items. That also is only a partial fix that only gets at the shifter part of the potential bias. There are two approaches that are potentially more comprehensive fixes. One, which is going to inspire much of our approach, is called anchoring vignettes, which comes originally out of the political science literature, a paper by King et al., and was applied to self-reported well-being by Kapteyn, Smith, and Van Soth. The idea, and then a number of papers since then, the idea is to give people vignettes and ask people to rate the life satisfaction of the people in the vignettes and use that as anchors for interpreting the responses that the people give to their own well-being. There have been a number of criticisms of this approach based on the concerns about biases in the way people answer these vignette questions. And econometrically, to implement the approach, you have to make a number of untestable distributional assumptions and functional form assumptions. And so perhaps because of these concerns, the approach has not been very widely adopted. Another way of trying to deal with scale use differences that comes out of the psychology literature involves response styles. So the idea here is to postulate that the way people use scales is common. They use the scales in the same way across different kinds of questions. So not just life satisfaction questions, but you could use then the way they answer other kinds of questions to adjust for the mean and variability of their responses on the, say, a life satisfaction question. That assumes the existence of a kind of general scale use that holds across questions. So that's something that I won't have time to get to it today, but it's something we can actually address with our data because we actually measure scale use across a number of dimensions. And the short summary is we find there's definitely correlation across different dimensions, but it's far from perfect correlation. So it's probably an incomplete correction. Okay, so what we're going to do in this paper is make two kinds of contributions, one on the theoretical side and one on the econometric side. So on the theoretical side, we're going to show that the anchoring vignette approach actually works under weaker assumptions than have been understood, which means that it's less subject to the concerns that have been raised against the approach. And then we're going to build our econometric approach on this generalized version of the anchoring vignette approach. And to build our econometric framework, we're going to start with an empirical observation, which is we find that a respondent scale use is approximately a linear transformation of other respondent scale use. And based on that observation, we can build that into the theory, and it turns out that allows us to develop econometric procedures that are much more attractive along a number of dimensions. And then, so what I'm going to do now is tell you very briefly about the data that this talk is based on, then show you some evidence of scale-use heterogeneity in general, and then spend a bit of time on the theoretical framework and the econometric approach, and then hopefully have a bit of time to show you an application and a few validation exercises. So our data comes from the Understanding America study, which is a nationally representative study in the US. It's an online survey. The talk is based on about 10,000 respondents who answered our survey questions. We asked 33 self-report questions about different dimensions of well-being, and they were all on a 0 to 100 scale. So here's an example of a question we asked about life satisfaction. We asked, over the past year, on average, how would you have rated how satisfied you are with your life? And we labeled the response scale 0 to 100, 0 labeled as lowest possible level, 100 as highest possible level. The reason we use those labels is that they're labels we could use across all the questions we were asking. They weren't specific to life satisfaction, so we could hold that constant. And then a person either moves the slider or types in a number, in this case 63, and then can move on to the next question. So we also had 33 what we call calibration questions, which is our generalized term for vignettes, because it includes not just vignettes, but other questions that are designed to measure scale use. And they were also elicited on a 0 to 100 scale. So of those 33 calibration questions, 21 of them were vignettes where for 7 different dimensions of well-being, we asked 3 vignettes, a trio of vignettes. So one of the dimensions that we study is how satisfied you are with your life. So to give you a sense of what that kind of question looked like, here's a screenshot that gives a little vignette as a person, and then asks, if this situation described your life during the past year, on average, how would you have rated how satisfied you are with your life? So this is one of the 3 questions. I won't read you the text for the 3 different vignettes, but they are designed to have some variation in the life satisfaction of the person described in the vignette. There's kind of a low, medium, and high level. We also, here are the 6 other dimensions where we had vignettes. Some of them are very narrow dimensions, like your ability to breathe in and out easily. We also have how happy you feel, you feeling anxious, so we included the things that are included on the ONS survey. And then we had 12 additional calibration questions that we call visual calibration questions. They were things like, how dark is this circle? And you rate on a 0 to 100 scale. So the idea here was to try to totally get away from the biases that are potentially present when people answer about vignettes and have something with a kind of objective answer. And then here are the 3 different levels for, these were also trios. Here are the 3 different levels of darkness of the circle. I'm actually not going to spend much time in this talk on these data because this is the kind of data we use to investigate how general is scale use, how similar is the scale use across dimensions, and as I mentioned before, it's not, we think we can get more correction for scale use by focusing on same dimension scale use. Okay, but here's some suggestive evidence that scale use heterogeneity is something that we ought to be concerned about. So what I'm showing you here on the x-axis is the average response that a person gives to a number of the vignette questions. So I've listed here the dimensions that we're including in this mean. So each point here is an individual, and their value on the x-axis is their mean response to this set of 3, 6, 9, 12, 15 vignette questions. And then the y-axis is their mean response on the 33 self-reported well-being questions. So we're just averaging over all these different dimensions. And what you see is there's clearly a positive relationship. The correlation is 0.4. And what that suggests is that people who are giving higher ratings on average to the vignettes are also giving higher ratings on average to the self-reported well-being questions. Here's another descriptive graph. This is about not the level of people's responses, but the variability of their responses. So what I'm showing you now, again, each point is an individual, but now the x-axis for the point corresponds to the standard deviation of their responses across this set of 15 vignette answers. And the y-axis is the standard deviation of their responses to the 33 self-reported well-being questions. And again, you see a positive correlation here. It's 0.24, which suggests that people who are giving more, people who are using more of the response scale when they're answering the vignettes are also using more of the response scale when they're answering the self-reported well-being questions. Okay, so it suggests that there's something going on here with scale use that matters for people's responses. In order to think more carefully about it and develop a framework for correcting for scale use adjustment, we need some theoretical structure. So that's what I'm going to get into next. So let me start with telling you about the anchoring vignette approach from the King et al. Paper. So they have, are imagining that we have 3 vignettes that are about people named Moses, Jane, and Allison, and 2 individuals in this picture. So person number 1 rates Moses here, Jane here, Allison here, and herself here. Person 2 rates everybody lower, Moses here, Jane here, and himself here. And the idea in the anchoring vignette approach is that you might have naively, looking at these ratings, thought that person 2 was worse off than person 1 because the rating is lower. But in terms of the ranking relative to the vignettes, person 2 puts themselves above Jane, and person 1 puts themselves below Jane. And that tells us that if we were to translate person 2's scale to person 1's scale, we'd see that actually person 2 is better off. So when they're describing their approach, King et al. Say that they have 2 assumptions. So the first is called response consistency, which is that each individual uses the response categories in the same way when giving the self-reports as when reporting on the vignettes. And the other assumption is vignette equivalence, which is that everyone is perceiving the vignettes in the same way. So there have been a number of concerns that have been raised about the way people answer vignette questions. And all of those concerns can be thought of as worrying that people differ in how they map, how their rating, about how their ratings map from vignettes, or about the mapping from vignettes to ratings. So that mapping might differ across people, which could violate both of those assumptions on the previous slide. So one concern that was raised by Angus Deaton is that people can't imagine situations that are very far from their own life. And so they, people who have experienced, having gotten cancer, then when they rate a vignette about somebody with cancer, they give a different answer. They rate it differently because people who haven't had cancer just don't really understand the situation of the person who had cancer. Another example of a concern is that with a vignette you can't mention all possible relevant details of a person's life. So what do people assume about what you don't mention? Maybe they fill in details of their own life, and then that means different people are going to perceive the vignettes differently or be answering different questions. Self-norming is the idea that people might rate the vignettes relative to themselves, and mood effects are, somebody's in a good mood, maybe that changes their scale use. So here's how, so let me tell you about our theoretical framework, which is going to be more formal than those two kind of verbal assumptions in the King et al. Approach, and they're going to let us think more carefully about these biases. So let's consider two people, let's say person I, and unlike in the King et al. Setup, or the key way we're going to think about these biases, is we're going to say that each person has what we call auxiliary conditions, which are variables that affect the mapping from vignettes to ratings. So this person person I has lambda I auxiliary conditions. There's some state space, so like this is, say, the possible situations you could have in your life. And then person I has some state in that state space. And then when they're asked a life satisfaction question and they give the answer 70, there's some function which, following Andrew Oswald, we call the reporting function. This is the function that tells us how that state maps to the response scale, and we're going to allow that to depend on the auxiliary conditions. For person I prime, who may have different auxiliary conditions in a different state, here's their answer, the 80. And the fundamental identification problem of scale use is that we don't know how to translate from person I 70 to where that would be on person I prime's scale, what we call the translation function from I to I prime. So what is the translation function? It's just the composition of R's of I prime's reporting function with the inverse of I's reporting function. So we go, starting from we take I's answer, we map it back to what that state is, and then we say if person I prime had that state, what would they say? So that's the translation function. We pick one person as the reference individual. So it's kind of an arbitrary choice. It doesn't matter. We're going to think of it as the average person. We call it I star, and they have kind of an average auxiliary position. lambda I star. And then we define, within this framework, there's no need for us to posit some true life satisfaction, some true underlying thing. All that's important for us, all that we're trying to do, is put people's ratings on the same scale. And so we can define, in place of having some notion of the truth, we're going to have what we call the common scale rating for some state, which is defined as what the how the reference person would rate that state. And once we define that common scale rating, we could think of the translation function, and I'll sometimes write the translation function as the reporting function, but instead of having it be a function of the state, I'm going to have it be a function of the common scale rating of that state. Okay, so let me give you a simple example to illustrate how introducing how we can formalize the response biases in terms of the auxiliary conditions, and why the framework, the approach, is actually robust to these concerns. So the simple example, I'm going to assume translation functions are linear. That's actually something I really will assume later in the econometric approach, although we don't need it now. And then the other thing, which I definitely is way stronger than necessary, is that I'm going to assume people misperceive the common scale level W, or the state, as a linear combination of what it really is and their auxiliary condition. So here's an example of a biased reporting function where person I, their reporting function is a linear function of the state. There's this kind of, their shifter parameter and their stretcher parameter times the state. So that's the linear translation function. But this bit in the square brackets is the misperception. And instead of mapping the state to the response, they're taking a linear combination of the state and their auxiliary condition. So you could think of this, for example, as the fill-in-the-blank bias. So here, if you think of the auxiliary state as just being their state again, it could just be W again, they're taking an average of the description, when they're answering vignette questions, of the description of the person in the vignette and their own state. So I'm just going to rearrange that and group some terms. Here's how people answer vignette questions. So this is just taking that same response function, but now this is for the state corresponding to what's described in the vignette. And again, so here's the averaging. So I'm assuming it's the same response bias across when they're answering about themselves or when they're answering about vignettes. Again, I can group terms in a similar way. And then the observation for this example is that we can define new variables, a new shifter that I'm going to call alpha, which is equal to this term, which is exactly this and this, and a new beta, which is this term, which is the coefficient on W in both of these expressions. And then if I substitute in with that change of variables, this is what I get for the response functions. And the key point is these alphas and betas, now they're functions of the auxiliary conditions and this mixing parameter, but they're fixed for each individual. So for all intents and purposes, I can just treat this as the relevant scale use. It's affected by the bias, but it's a scale use parameter that if I then want to estimate and correct for scale use, the auxiliary conditions don't matter anymore. And what I'm going to show you next is that this example generalizes, beyond this kind of linear combination case and without assuming a linear translation function, as long as, and this is really going to be a key thing, the auxiliary conditions don't change the way people ordinarily rank vignettes. Now, there still may be concerns. It may still be the case that somebody who has had, if somebody who has had cancer thinks of any vignette about somebody with cancer as now worse than, all other medical conditions, and that's different than somebody who hasn't had cancer, then that's still going to be a problem for this approach. But it's, I think the main sorts of examples that we're worried about, which is just that things like, what you've experienced matters at all for the way you rate vignettes, that milder version is not going to be a problem for this, for the anchoring vignette approach. Okay, so here are our assumptions. In playing the role of vignette equivalence in our framework is an assumption we call common ranking of vignettes, which I was just alluding to. So the assumption is that the reporting function for vignettes for person I, holding fixed their auxiliary conditions, is a positive monotonic transformation of the reporting function for vignettes for person I prime. So that is to say, their numbers may be different, but they're ranking the vignettes the same way. We think the main way that that's likely to fail is when you have a broad dimension of well-being, like life satisfaction, because people might, the fundamental aspects of well-being that enter into overall life satisfaction, people might weigh them differently, and that would lead to potentially different rankings of vignettes that have different levels of the aspects of well-being. But we think it's more likely to hold for narrow dimensions of well-being. And we want to point out that this assumption is testable. It's not testable at the individual level, because if there's noise in people's responses, you could have differences in rankings that are just due to noise. But at the group level, this assumption implies, it predicts, that individual characteristics shouldn't be correlated with systematic differences in vignette rankings. Okay, so the second assumption is a weakening of the response consistency assumption. So remember that the response consistency assumption was that people use the response scale the same way when rating vignettes as when rating the self-report questions. We're only going to require that you get that kind of response consistency when we hold fixed the state. And so for person I, who's always answering questions with the same auxiliary conditions, the point here is that if the state in the vignette matches the state they're actually experiencing, then they would give the same numerical rating. So we think this is plausible as long as the respondent is being honest in answering the survey and can recognize when the vignette is actually describing their own state. And I'm not writing this down as a separate assumption, but it's sort of going to be an implicit assumption. I'm going to assume that, that any state could be described by a vignette. And in particular, I'm going to make use in the proofs, which I won't show you, we're going to make use of hypothetical vignettes that are basically like saying, I have this my state, whatever it is. Imagine there were a vignette that described my state. How would I rate that vignette? Well, I know from this assumption that it would be the same as how I rate myself, and then I'm going to use that, the relative ranking of how I would rate the vignette describing me relative to the other vignettes to get results. Yeah?
Sorry. What's the sense in which this is a weakening of the standard response consistency assumption?
So I'll slightly back off of that claim because King et al. Are kind of vague. They didn't write down a formal model, so it's hard to say whether this is a formalization or a weakening. But the reason why we think of it as a weakening is that the response consistency assumption, I can go back to it to look at exactly what they say. So they say each individual uses the response categories for a particular survey question in the same way when providing a self-assessment as when assessing each of the hypothetical people in the vignettes. So they're saying for all the vignettes, using the response category the same way that they're answering about themselves. Our assumption is only that they're going to use the response scale in the same way for a vignette that describes themselves as they rate themselves.
Daniel, can I jump in with a question?
Yeah.
Am I correct in concluding that assumptions 1 and 2 together imply that there's interpersonal comparability in an ordinal sense? Like if I give a higher answer to the life satisfaction question, then I have a higher omega than you, or vice versa.
That's exactly right, Leonard. You're anticipating my next slide. Great question. So here's the result that we prove based on those assumptions. So we take any two individuals, I and I prime. Two things are now true. One is that their self-reporting functions agree with each other on the ranking of all states. And exactly as Leonard was saying, that implies there's an ordinal interpersonal comparability of the states. Second result is that if person I ranks their own state higher than some vignette, and person I prime ranks their state as lower than some vignette, then person I would rate themselves higher than they would rate themselves if they had person I prime state. So that is to say, this is exactly that picture that I showed you of the anchoring vignette approach. This shows that the anchoring vignette approach is valid under these assumptions. This also implies that the translation function for vignettes, which is observable because we can measure how everybody answers the vignette questions and construct the translation function for those, we can use that as if it were the translation function for the self-reports, and that's going to be right ordinally. So that's really that's how we can use this framework to correct for scale-use differences. Okay, so now I want to move on to the second contribution on the econometrics. So let me start again by telling you the state of the play at present, which is that King et al. Proposed two approaches, and they're the main two approaches that are used, although the first one is very rarely used, and that is a fully non-parametric approach where you code responses, answers to the self-report question, answers to the vignettes on an ordinal scale, and then you look at essentially whether how the distributions, where people put themselves relative to the vignettes. The problem is means and regressions and the kinds of things we want to do they don't make sense with an ordinal scale. So it's pretty limited what you can do, and it's also not clear how you deal with ties, which are pretty frequent when people are using Likert scales with just 5 responses. So the main approach that's used is called the Chopin approach, which is essentially ordered probit, where you have the thresholds for the ordered probit themselves be functions of individual level characteristics. So not just the say life satisfaction being a function of the observed demographics of person I, but also the thresholds that they're using for the response scales, which you identify. You identify these coefficients for the response scales based on the responses to vignettes, and then you use that to estimate the beta coefficient for the self-report questions. So there are a few concerns we have about the Chopin approach. First of all, it started as this ordinal, an approach to dealing with ordinal data, but then it gives that up by assuming that there's this latent variable that's normally distributed, and you have a functional form for the threshold. And so these are untestable assumptions, and the same kinds of concerns that Bond and Lang raised about using ordered probit type approaches for life satisfaction questions, when you don't deal with scale use, carry over to when you do incorporate scale use differences. Because imposing these restrictions, if they're not correct, can actually cause misspecification in the model. It's also, once you estimate it, it's hard to interpret the result because you have these parameters, you have as many parameters as you have demographics for each threshold. So that's a lot of parameters. And you're only, in the end, only allowing scale use to differ by observed demographics. And actually, I'm not going to show you these results, but we find that there's more scale use heterogeneity within demographic categories than across demographic categories for what we've measured. It also basically doesn't work when you have a lot of response options. Okay, so we're going to, now I'm going to tell you about our econometric contribution. And it's going to be based on introducing this strengthening of our assumption 1. So remember, assumption 1 was that the answers to the vignettes were monotonic transformations of each other across people. We're going to strengthen that to assuming that they're positive affine transformations, or linear transformations. So I want to convince you first that that's actually a reasonable approximation. And it's not, and so I'm going to show you our data, but then I'm going to show you it actually, we went back to other people's data where they collected data on vignettes, and it also holds in their data. Okay, so I'm going to show you, this is from our data. These are our different vignette dimensions. Those are the colors. And what I'm going to do in each of the next few graphs is split the sample in half. So the x-axis, so each point corresponds to one vignette question. So there's 3 vignette questions per dimension here. And I'm going to tell you, say for this one, which is, that's the happiness vignette. This is the low vignette for happiness. The mean answer to that vignette for people who were below median age in our sample, which is about 35, and the mean response to that question for people who were above median age in our sample, which in this case is about 30. And what you see is that for those 3 happiness question dimensions, let's see where the third point is, but somewhere up there, this is the best fit line. You can see that the points fall pretty close to that line. And that's actually true for all of these dimensions, so for the age splits. The correlations are extremely high, very close to 1. Here is the split by below median income and above median income. And again, in most cases, you see pretty good fits from the lines for each dimension, although they're different across dimensions. Is employed full-time against not employed full-time. Didn't graduate college versus graduated college. Women versus men. This is black, not black. Okay, so that was our data. This is data from King et al.'s paper. They get self-report or vignettes about political efficacy. The fit here is not quite as good, but if you look at answers of their respondents in China and the respondents in Mexico, that there's a almost 0.8 correlation. Here is below and above median age broken down by country, and here you can see certainly within country we're getting very good fits. Men versus women, below and above median education. Here's yet a third data set. This is from the SHARE data, which is the international European health and retirement type studies. This is less clean because they only have 1 vignette per dimension. But even if we just pool all of those, which is what we're doing here, and just graph them, you can see that it's actually pretty well fit by a line. Those are across dimensions, and similarly if we cut by countries in the shared data, it's a pretty good fit. Okay, so now I want to be clear. We do test at the individual level for linearity. We can statistically reject it, You know, the p-value we can get to be very small in a large sample. But if you look at the magnitude of the deviations from linearity at the individual level, they're pretty small. So besides being a reasonable approximation empirically, assuming linear translation functions is going to help simplify things a lot in the analysis. And it's attractive theoretically because it allows us to do things like run regressions that we want to do. And it's going to mean that the ratios of regression coefficients don't depend on who we pick as the reference individual. And then it's going to allow us to do things like calculate analytically what the bias is if you fail to correct for scale use, which is basically impossible to do with a complicated maximum likelihood model. Okay, so now I'm going to drop the auxiliary conditions from the notation because it's not going to matter. So our econometric model starts with our linear translation function, and we're going to add error terms. So this is the common scale self-reported well-being that shows up, which is in this case, it's the definition we're using is it's the mean level, it's the W for person I is how people on average would rate themselves if they had the state of person I. And there's a shifter and a stretcher parameter. So we're adding error terms. One of them we call the perception error. That's at the level of perceiving the state. And the other one, which we call the trembling hand error, is at the level of the response, the number that you give. And for the econometrics, we're going to need to assume something about correlation among errors. We're going to start with the simplest version of the assumption, which is just that everything's independent of everything. That can be weakened at the cost of making the econometrics a little more complicated. Okay, so it would actually be pretty straightforward to correct for scale use at the individual level if you could have lots of vignettes per person. Because if you had lots of vignettes per person, then what you could do is estimate the translation functions at the individual level, estimate how people's vignette ratings relate to the average vignette ratings, and essentially just use OLS, regress a person's vignette ratings on mean vignette ratings, and you get their shifter and stretcher parameters. And then you could just invert the translation function and get back to the W and do the analysis of the W. The problem is that while we think it's reasonable to think that we're going to have a lot of people in our sample, we think it's basically never going to be the case that we have a lot of vignettes that we've measured. And so what that means is that if we think about our individual level corrected measure of well-being, which would be subtract the shifter, divide by the stretcher, we're going to be dividing by something which is very noisy, can be end up being close to zero. And so that leads to a lot of bias and a lot of noisiness in the estimates. And we've actually tried it. The estimates look so ridiculous that I can't even show you on a slide, even if we trim the observations to get rid of the worst bias. So what we're going to do instead is derive estimators that give us the moment of the distribution of W that we need for an application. And so because intuitively they're not going to be doing things at the individual level, we're going to be doing things at kind of the average level within demographic groups, and that's going to avoid this problem. So we actually derive, 3 estimators in the version of the paper that's public, 2 in probably the revised version. But I'm going to focus on, for the talk, just telling you briefly about the simpler method, which is a method of moments approach. And I'm going to focus on one moment of the distribution of W, which is the one relevant for running regressions, which is the covariance of the well-being measure with a demographic, which I'll call X. So how does the method of moments work? Well, it starts the same way you would start with an individual level correction. We run an OLS regression for each individual. We run an OLS regression of that person's vignette ratings on the mean vignette ratings in the sample. And that gives us estimates at the individual level of alpha and beta, so alpha hat and beta hat. But instead of using those directly to correct for the response, we're going to construct for each, and use these estimates, these alpha hat and beta hat estimates, to construct for each individual what we call a mean match benchmark, which is an empirical analog of this translation function. And we're going to evaluate it at the average level of, say, life satisfaction in the sample, if this is a life satisfaction question. So what is that doing? It's saying, what would, if we didn't know anything about person I, we didn't actually observe what their answer was to the life satisfaction question, and all we knew was how they answered vignettes, so we have estimates of their scale use. What would we predict about how they would answer the life satisfaction question? So taking the mean answer in the sample to life satisfaction, what would we predict based just on scale use? And then we run a regression of that mean match benchmark variable on demographics. And that tells us how the demographics are related to the scale use. And notice, these are very noisy, these estimates alpha and beta at the individual level, because we don't have very many vignettes. But it doesn't matter because this is now a left-hand side variable in our regression. Okay. So I'm going to show you the results from running this regression. But the last step in the method of moments is once we get these coefficients, they are exactly what we need to adjust the life satisfaction regression by in order to get a scale use adjusted result. So let me be concrete about that here with this example. So this is, I'll focus on this first column, which is a regression of the mean match benchmark for life satisfaction. So again, the left-hand side here is constructed from the answers that people gave to life satisfaction vignettes. And we're regressing what we predict about how they would answer a life satisfaction question based only on their scale use on a set of demographics. We have more demographics in the regression, but I'm just showing you some of them here. And so, for example, we see that people who are older are giving lower answers on average to the vignette questions about life satisfaction, and people with higher income are giving higher answers on average. College grad also shows up as significant. These are false discovery rates. So we have that for all of these different dimensions that we look at. And then, how do we use this adjustment? So now what I'm showing you in this table is in the first column, this is a standard life satisfaction question, like the ones in the literature. So I'm just regressing life satisfaction on the demographics. And so, higher income, higher life satisfaction. If you're unemployed, lower life satisfaction. So generally pretty similar results to what you see in other data. And then I'm going to compare it in different columns to different kinds of adjustments. So here, the last column is the Chopit approach after some rescaling to put it on a comparable scale. And the method of moments approach that I just talked about is this column here. And the way you get the coefficient for, say, on age is very simple. It's a super simple approach, because you saw that the mean match benchmark regression was just an OLS regression to construct the mean match benchmarks for each individual, and then an OLS regression on demographics to get those adjustments. And to remind you, it was like -1 was the coefficient on age. So when we come back here, the difference between the unadjusted and the adjusted is 1. It's exactly what that coefficient was from the other regression. So if you want to see what adjustments are significant, you get that from looking at this regression. This tells you which coefficients are going to statistically significantly change when you do scale use adjustment, and then you add them to what the unadjusted coefficients to get the, or subtract them from the unadjusted coefficients to get the adjusted results. Okay. So, so I'll skip that. All right, so let me just say, tell you about a couple more results that I think are particularly interesting. One is a validation exercise that is inspired by something Andrew Oswald did in his early paper, pointing out the potential concerns about scale use differences. He focused on height. We're going to look at height and weight. So we have some data. This is actually different data we collected in an online sample. But we asked people their actual height and their actual weight in inches and in pounds. Sorry, I'm American. And then in this first row, what we're doing is regressing their subjective height on a 0 to 100 scale on their objective height, and we get a coefficient of 0.5. And their subjective self-reported weight on the 0 to 100 scale on their objective weight is 0.4. These are standardized variables, so you might hope that they would be 1 if you were getting subjective answers that perfectly correspond to the truth. Although they might be bounded, they might be below 1 if people's subjective perceptions differ from objective reality. But what I'm going to show you is that when we do our kind of full scale use correction, which is this third row here, where we correct both the ratings and the standard deviations of the ratings, just based on a different moment of the distribution of W that I didn't tell you about, but is also doable. And then you run the same regressions, you get much higher, much stronger relationships between the objective and subjective variables. So it's hard to know if we're fully correcting for scale use differences, but we're certainly improving relative to not adjusting. This is a bit of a messy graph because we just produced it yesterday and I haven't had a chance to make it clean yet. But one important difference between everything I've been talking about and the literature is that I've been talking about variables measured on a 0 to 100 scale, and most of the literature is a Likert scale with just a few response options. And you might worry, well, I mean, it turns out that it doesn't much matter. Even though, with just a Likert type scale, you might think an OLS regression type thing is going to be badly misspecified, and if we do this in the Understanding America study, we were able to exploit the fact that that a few months before we ran our survey, they had run another survey that asked a life satisfaction question on a 1 to 5 scale, so a totally standard question. And so we can do exactly our adjustment with that question and compare it to what we get when we adjust our 0 to 100 question. And this is showing each of the demographic coefficients. And you see here a 0.9 correlation in the adjusted answer. Okay, so what do we recommend? Well, we think that people should be doing scale use correction, and that there's several existing data sets, like the ones that I talked about, that I mentioned in this talk, that have vignette questions where you could already do it. There's also a Dutch survey that collected vignette data. And we think another implication is that when people are running their own surveys, they should incorporate vignettes into their surveys. And one thing I haven't emphasized, but I think may be useful to keep in mind for something like government efforts, or cases where there are budget constraints, is that you don't actually need to measure the vignettes on the whole sample. You could do it on a subsample and estimate what the correction should be, and then apply that to regression results that you run on the full sample. That may make it more doable. Okay.
Thank you, Dan.
Exactly 6 o'clock.